I will give you an idea about the scales, the topic named scales. See, the dimensions of large objects must be reduced to accommodate on standard size drawing sheet. This reduction creates a scale of that reduction ratio, which is generally a fraction. So that scale is called a reducing scale, and the ratio, which is called as RF, or representative factor. Similarly, in the case of tiny objects, like for example the gear in the inside of a watch, the dimensions must be increased for the above purpose. Hence, this scale is called enlarging scale, and that ratio is called RF, or representative factor, which is more than unit. For full size scale, the RF is 1, or scale 1:1, means the size of the drawing and the size of the object are equal. The other representative factors are 1:10, 1:100, or 1:1000, 1:1 lakh, etc. The following equations are very important if you are dealing with the scales, and the first equation is representative factor, or RF. The equation is the dimension of drawing divided by dimension of the object, or length of the drawing divided by actual length, or square root of the area of the drawing divided by actual area, or cube root of the volume as per drawing divided by actual volume. And the second equation is length of the scale. Length of the scale is representative factor into maximum length to be measured. And these units are very important while you are dealing with the scales. And 1 kilometer, which is equal to 10 hectometers, 1 hectometer is equal to 10 decameter, 1 decameter is equal to 10 meters, 1 meter is equal to 10 decimeters, 1 decimeter is equal to 10 centimeter, and finally 1 centimeter is equal to 10 millimeters. The various types of scales used are plane scales, diagonal scales, vernier scales, comparative scales, and scale of thoughts. So now I will explain the first 3 scales. That is plane scale, that is for dimensions up to single decimal, and the diagonal scale and vernier scale is for dimensions up to 2 decimals. First question is a plane scale. This plane scale is a type of scale which represents 2 units, or a unit and its subdivision. The first question is problem number 1. Draw a scale 1 centimeter is equal to 1 meter to read decimeters, and to measure a maximum distance of 6 meter, and show on it a distance of 4 meter and 6 decimeter. So first of all, our aim is to calculate the RF. RF is representative factor. The equation is dimension of the drawing divided by the dimension of the object. So dimension of the drawing, which is given as 1 centimeter, and the dimension of the object is 1 meter. So 1 centimeter divided by 1 meter, and which is equal to 1 by 100. And length of the scale, which is equal to representative factor into maximum distance. So RF is 1 by 100, 1 by 100 into maximum distance. So in the question, the maximum distance is given as 6 meter. So convert it into centimeter. So 6 into 100 centimeter, which is equal to 6 centimeter. So next step is draw a line 6 centimeter long and divide it into 6 equal parts. So divide the line, the 6 centimeter long line, and divide it into 6 equal parts, and each part will represent 1 meter. And next subdivide the each part is represented as 1 meter, and the first part is divided into 10, and which will represent the second unit or a fraction of first unit, and place 0 at the end of the first unit. Number the units on right side of 0 and subdivisions on left hand of 0. Take the height of the scale 5 to 10 millimeter for getting a look of scale, and you can see the meters and decimeters are marked on the scale, and the representative factor is mentioned below the scale. So RF is equal to 1 by 100, and this is a plain scale showing meters and decimeters. So our aim is to mark a distance of 4.6 meter, which means 4 meter and 6 decimeter. So we can mark 6 decimeter on the subdivision and 4 meter on the main division. So this represents 4 meter and 6 decimeter, which means 4.6 meter. And the second question is, in a map, a 36 kilometer distance is shown by a line 45 centimeters long. Calculate the arc and construct a plane scale to read kilometers and hectometers for maximum 12 kilometer. Show a distance of 8.3 kilometer on it. So RF is equal to distance on drawing by distance on object. So distance on drawing is 45 centimeter and distance on object is 36 kilometer. So 45 divided by 36, and the numerator and denominator have different units, so it convert it into same units, and you will get the RF is 1 by 80,000. So length of the scale is RF into maximum distance. So 1 by 80,000 into, as per the question, the maximum distance is 12 kilometer. So into 12 kilometer, and you will get the length of the scale is 15 centimeter. So draw a given line, and the length of the line is 15 centimeter, and divide that line into 12 equal parts, and each division represents 1 kilometer. So divide the 15 centimeter line into 12 equal parts. So I divide the into 12 equal parts, you can see, and I divide the first block into 10 equal parts, and so this is the scale, and the height of the scale will be 5 to 10 millimeter for getting a look of the scale. So kilometers and hectometers are shown in this scale. Kilometers will be on the main division and hectometers will be on the subdivision. The RF is equal to 1 by 80,000, and this is a plane scale showing kilometers and hectometers. And in the main scale you can take 8 kilometer, and in the subdivision take the third division, which is 3 hectometer, which means 0.3 kilometer. So this is 8 kilometer and 3 hectometer. And the next question is, the distance between two stations is 210 kilometer. A passenger train covers the distance in 7 hours. Construct a plane scale to measure time up to a single minute. RF is 1 by 2 lakh. Indicate the distance travelled by train in 29 minutes. So first of all, we calculate the mean speed of the train. So the distance is 210 kilometer, and the time is 7 hours. So we know the equation, speed is equal to distance by time. So mean speed of the train is 30 kilometer per hour. So which means the train cover 30 kilometer within 60 minutes. So length of the scale is equal to RF into maximum distance per hour. So 1 by 2 lakh into, so per hour the train cover 30 kilometer. So into 30 kilometer you will get 15 centimeter. So draw a line of length 15 centimeter and divide that line into 6 equal parts. So this is the plane scale. So the bottom will represents the time. So this is the bottom will represents the time, which is 60 minutes, and the top will represents the kilometer. So our aim is to find out the train, indicate the distance traveled by the train 29 minutes. So in the bottom scale you can see, you will get 20 minutes on the main scale, and take the 9 divisions on the sub division, and you can see that will be the 29 minutes. So in the 29 minutes the train will cover 14.5 kilometer, which will be shown on the scale. So this is scale. So the RF and the RF is represented, and this is a plane scale showing kilometers. Next is the diagonal scale. So we have seen that the plane scales give only 2 dimensions, such as a unit and its subunit or its fraction. So next is the diagonal scale. So the diagonal scale is a scale gives us 3 successive dimensions, that is a unit and the subunit and a subdivision of a subunit. The principle of construction of a diagonal scale is as follows. Let the xy in the figure be a subunit. So from y, draw a perpendicular yz to a suitable height. Join x and z. Divide the yz into 10 equal parts. Draw parallel lines to xy from all these divisions and number them as shown in the figure. So from the geometry we know that similar triangles have their like sides proportional. So consider 2 similar triangles, x, y, z and 7 dash 7 z. We have 7z divided by yz is equal to 7 dash 7 divided by xy, each part being 1 unit, which means 7 dash 7 is equal to 7 by 10 xy, which is equal to 0.7 xy. Similarly 1 dash 1 will be 0.1 xy, 2 dash 2 will be 0.2 xy. Thus it is very clear that the sides of small triangles which are parallel to divided lines become progressively shorter in length by 0.1 xy. So the solved examples on next pages will make the principles of diagonal scales very clear. So the first question is, the distance between Delhi and Agra is 200 km. In a railway map it is represented by a line 5 cm long. Find its representative factor. Draw a diagonal scale to show single kilometer and a maximum 600 km. Indicate on it the following distance: 222 km, 336 km, 459 km, 569 km. So our first step is to calculate the RF. So RF is distance on drawing divided by distance on object. Here the distance on drawing is 5 cm and the actual distance is 200 km. So you will get the RF 1 by 40 lakh. And next is to calculate the length of the scale. RF into maximum length to be measured. The maximum length is 600 km and you will get the length of the scale is 15 centimeter. So first of all, draw a line 15 centimeter long. So this is the line, the length is 15 centimeter, and divide that into 6 equal parts, and each division will represents 100 kilometers. Divide the first division into 10 equal parts and take the height will be, say, you can take any convenient length to take upwards, and divide the left side into 10 equal parts as shown in the figure, and join the ninth portion and the left topmost point as shown in the figure, and draw parallel lines from the bottom points. So draw the parallel lines. So the RF is 1 divided by 40 lakh, and this is the diagonal scale showing kilometers, and our first is mark 569 kilometer. So you can mark 500 in the main division, and 60 in the secondary division, and 9 will be in the diagonal division. So this is the 569 kilometer, and the second is 459 kilometer. So take 400 in the main scale, and 50 in the secondary scale, and 9 in the diagonal scale. So this is the 459 kilometer. And the third one is 336 kilometer. So you can take 300 from the main scale, and 30 from the secondary scale, and 6 from the diagonal scale. So this is the 336 kilometer. And next is the 222. So you can take 200 from the main scale, and 20 from the secondary scale, and 2 division from the diagonal scale. So this is the marking 222 kilometer. So next is the problem number 5, a rectangular plot of land measuring 1.2 hectares, which is represented on a map by a similar rectangle of 8 square centimeter, 8 centimeter square. Calculate the RF of the scale. Draw a diagonal scale to read single meter. Show a distance of 438 meter on it. So first of all, we know that 1 hectare is equal to 10,000 square meters. So first of all, we calculate what is 1.2 hectares. So 1.28 hectares is 1.28 into 10 raised to 4 and 10 raised to 4 centimeter square. And 8 square centimeter area on the map represents 1.28 into 10 raised to 4 in 10 raised to 4 square centimeter of land. So 1 centimeter square on map represents 1.28 into 10 raised to 4 in 10 raised to 4 divided by 8 square centimeter on the land. So 1 centimeter on map represents a root of 1.28 into 10 raised to 4 into 10 raised to 4 by 8 centimeter. So 1 centimeter on the drawing represents 4,000 centimeter, means RF is 1 is to 4,000, so 1 by 4,000. So assume a length of scale is 15 centimeter, and that 15 centimeter will represent a length of 600 meter. So draw a line. The length of the line is 15 centimeter, and divide that into 6 equal parts, which means each division represents 100 meter. And divide the first division into 10 equal parts, and this is the upward height, and mark the divisions, and divide the left hand side and draw parallel lines as shown in the figure, and divide the left hand division into 10 equal parts, and join the 9th division and the top left diagonal point, the 10th point as shown in the figure, and draw parallel lines from the other points as shown in the figure. You can see that, and our aim is to mark 438 meter on it. So you can take 400 meter from the main scale and 30 meter from the secondary scale and 8 meter from the diagonal scale. So this is the 438 meters and the RF and the diagonal scale showing meters as shown in the figure. And next is the draw a diagonal scale of RF is 1:2.5 showing centimeters and millimeters and long enough to measure up to 20 centimeters. So first of all, the RF is 1.25 which is given, and the length of the scale is RF into maximum length to be measured, and the maximum length to be measured is 20 centimeter and which is equal to 8 centimeter. So draw a line and which is 8 centimeter and divide that into 4 equal parts, which means each division represents a length of 5 centimeter. So this is the diagonal scale, and again divide the left hand side into 10 equal parts and the bottom left portion into 5 equal parts. So this is the centimeter and millimeter. So join the bottom left point and the 10th point, the diagonal point, you can see as shown in the figure, and draw parallel lines as shown in the figure. So our aim is to mark a distance of say 13.4 centimeter. So you can take 10 meter from the main scale and 3 meter from the secondary scale and 0.4 centimeter, 0.4 meter from the diagonal scale as shown in the figure. So comparative scales that will be discussed later. So this is another type of scale. I will not explain this scale. So I will move on to the vernier scale. So this is the vernier scale, and vernier scales, these scales like diagonal scales which are used to read to a very small unit with a great accuracy. It consists of two parts. It consists of a primary scale and a vernier scale. The primary scale is a plane scale which is divided into minor divisions. As it would be very difficult to subdivide the minor divisions in ordinary way, it is done with the help of a vernier. The graduations on vernier are derived from those on the primary scale. So from the figure, it shows a part of a plane scale in which length AO, you can see the length AO which represents 10 centimeter. If we divide AO into 10 equal parts, you can see each division will be 1 centimeter. Now it would not be easy to divide each of these parts into 10 equal divisions to get measurements in millimeters. So now if we take a length BO which is equal to 10 plus 1 equal to 11 such equal parts, thus representing 11 centimeter, and divide it into 10 equal divisions. Each of these divisions will represent 11 by 10 which is 1.1 centimeter, and the difference between one part of AO and one division of BO will be equal to 1.1 minus 1.0 which is equal to 0.1 centimeter or 1 millimeter. This difference is called least count of the scale or LC, which means the minimum this distance can be measured by this scale. The upper scale BO is called the vernier. The combination of the plane scale and the vernier is called the vernier scale. So this is the first question on vernier scale. Draw a vernier scale. The RF is 1/25 to read centimeters up to 4 meters, and on it show a length of 2.39 meter and 0.91 meter. So our first aim is to calculate the length of the scale. RF is given, so length of the scale is RF into maximum length to be measured. So maximum length here it is 4 meter. So the length of the scale will be 16 centimeter. So this is the main scale, and the length of the main scale is 16 centimeter, and divide that main scale into 4 equal divisions, you can see, and divide the first division into 10 equal parts, and take one single division from the secondary division and mark the vernier scale as shown in the like yellow color, and divide it into 10 equal parts, so as shown in the figure. And this will be meters, and our aim is to mark 2.39 meters and 0.91 meters. So in the main scale you can mark 1.4 meters, and from the vernier scale 9th division, so you just add the vernier scale division and 1.4 meter from the main scale, you will get 2.39 meters, and in the main scale you will get 0.91 meter is marked in the vernier scale. Next is a map of size 500 cm by 50 cm wide, which represents an area of 6250 square kilometers. Construct a vernier scale to measure kilometers, hectometers and decameters, and long enough to measure up to 7 km. Indicate on it a distance of 5.33 km and 59 decameters. First of all, calculate the RF. Here area is given, so the square root of area of the drawing divided by actual area. So from that you will get the RF is 2 by 10 raised to 5. So and length of the scale is RF into maximum length to be measured, so you will get 14 cm. So draw a line and the length is 14 cm, and divide that main scale into 7 equal parts, and each division will represent kilometers, and subdivide each part into 10 equal parts which represents hectometer, and take 11 parts of hectometer part length and divide it into 10 equal parts. So this yellow color represents the vernier scale, and divide it into 10 equal parts, and each division will show 1.1 hectometer or 11 dm, and covering in a rectangle complete scale. So first of all, calculate the mark the distance 5.33 meter kilometer. So in the main scale you can mark 5 and 0.33 kilometer from the vernier. So this is shown in the figure, and the second is the 59 decameter. So this also shown in the left side, 59 decameter. So these three are the three different types of scales, that is plane scale, diagonal scale and vernier scale.